Everyone, it is Friday morning and welcome to our SOLIDWORKS Simulation webinar for this morning. Thanks for taking the time in joining us. My name is Joelle Guénette. I am the Territory Manager for Eastern Canada for SOLIDWORKS, and with me is Michel Cloutier, the Territory Technical Manager for the same area, and we've invited you to this session this morning to go over our simulation mechanicals, so FEA simulation solutions that you can take advantage of. And it gets a little overwhelming sometimes when we put these products and these solutions in different bundles to understand exactly what's in that. And then we end up with people who have these solutions and don't know exactly everything that they could take advantage of, or people who are looking at these solutions and want to make the right decision for their company and for what they want to do. So I just want to start by introducing the concept of why simulation. There's a number of reasons why you want to do simulation. One of the first one that comes to mind for me is the savings in cost and time for your company in having to possibly alleviate some of the prototypes that you have to do some physical testing, which is the traditional way of doing simulation. So bringing it in the virtual world, in the SOLIDWORKS environment, could potentially save you in having to only do one prototype at the end to do a final validation. And that for companies is a lot of time and a lot of money. So obviously along the way, simulation helps you make better decisions in your design, and then helps you also have a better confidence in the quality of your product and the quality of your design. So that's another aspect that it brings to the table. And the third thing I think is really important is that it gives you flexibility for innovation. And companies today are looking for different ways to differentiate their products, and obviously innovation is the way to achieve that in differentiating yourself and your offering, either being more flexible in what you're offering to your customers or just plain offering something that's just more innovative. So simulation gives you that what if scenario, being able to do that while you're in the design mode and trying to test different things, again, without having to go to prototype, without having to wait to see if it's going to work or not, giving you some freedom in that and letting you be more creative and more innovative. So with that, I won't take more of your time. I'm going to pass this over to Michel. Michel has been with SOLIDWORKS for over 12, 13 years now. And I have lost count along the way. He's seen our products go from the SOLIDWORKS CAD to adding simulation and more simulation and more simulation. And we're not going to be able to touch everything today. We've done other sessions on plastics that you can go see the recordings of. And SimFlow is a completely different module as well. We're going to focus on the FEA tools today and give you a flavor of that. And with that, Michel, I will turn it over to you.
Well, thank you, Joelle, and welcome everyone. First of all, like Joelle said, we're going to do an overview of the different simulation packages and what they're comprised of. Now, before we get going, in the GoToWebinar interface, there's a couple of things you can do there. There's a question box, so if you have any questions, type them in. If I don't have time to answer them during or after the session, I'll follow up via email. There's also a section called Handouts, and I've put a couple documents in there. So if you're curious about some more in-depth information, just go and dig that data out. So let's get to it. So when we talk about simulation, there's really two things that differentiate the simulation bundles. And I'll talk about the bundles a little later. But there's basically one of these two things that's going to make or break basically your decision on which bundle to purchase or to use. So first of all, there's the types of simulation you can do, and that will vary depending on the bundles. But also some of the productivity tools included in them, right? And I'll expand on actually both of them as I go through the presentation. So first of all, we have three packages in simulation right now: Simulation Standard, Simulation Professional, Simulation Premium. Follows a little bit the trend with SolidWorks Standard, Pro, and Premium. So as you go and as you up from Standard to Pro to Premium, you'll have more and more capabilities. So let's start with Simulation Standard and see what's included in Simulation Standard. So Simulation Standard, for a lot of people, will be the foot in the door of real FEA. So what we will find in Simulation Standard are going to be these three types of simulation. So we're going to find linear static for parts and assemblies, time-based motion, and fatigue analysis. Now, for some of you out there that might actually be using SolidWorks Premium, you know that some of these are actually in SolidWorks Premium. For example, linear static is in there, and time-based motion is in there. But SolidWorks Standard has that difference that it also adds fatigue, also adds a really nice, interesting tool, and that's one of the productivity tools that we're going to find is going to be called the trend tracker. And I'll expand on each of those components. So first things first, what's linear static? Usually linear static is the first type of simulation we do, especially in machine design, with metallic parts. So this is going to be, the basic mechanical resistance on parts and assemblies. Oftentimes when you're doing machine design, you're looking for stress, yes, displacement, yes, but also factor of safety. So that's going to be something that we're going to be able to do with linear static. It's going to, like I said, check for stresses and displacement, for performance quality of the parts, the components. The idea there is obviously to avoid failure and decrease over dimensioning. And I'm actually going to show a couple of these. So this is the first tool you get with Simulation Standard, right? The first type of simulation is linear static. Again, with that, you can also evaluate design change and to enhance the product quality. Now, one of the productivity enhancements that we find in Simulation Standard that's not going to be in SolidWorks Premium, for example, is going to be the trend tracker. Now, the trend tracker is really a useful tool. Think of it as your simulation diary. That's a little bit how I like to compare it. Basically, it will detect trends in different iterations. So it will keep track of what changed and actually record stresses over your design changes and displacement and weight and all that information. And actually, I'd like to show you both linear static and trend tracker a little bit. So let's jump into SolidWorks real quick. And we're going to use this part, a fairly simple part, right? Now, I could be doing this in either parts or assemblies, doesn't really matter. But SolidWorks Simulation is an add-on. So first things first, I'm simply going to, add the simulation capability. So a simple click, and now you'll see the new simulation tool tab coming up. So I'm going to create a new study. And like I said, these are all the various types of study. We're concentrating on linear static, so that's what I'm going to select. Okay. The setup is real quick. First of all, the material is already set because it actually captured the material from my SolidWorks part. So if I set the material inside of SolidWorks, I'm good to go. The one thing I'm going to start with is simulate how this is going to be held in place in real life. Now, using the fixtures, I can define, how this is going to be actually attached. And the things I like to show a lot is, as I select through these options, I got these little videos right here playing, showing me what type of fixture is this going to be. So for this case, I'm going to start with a simple fixed geometry. I go on the SolidWorks model, select my entities real quick. And when I'm confirm, I click OK. You got that visual cue on the screen, those little arrows, showing me the type of fixture and the direction of it. Second thing, I'm going to apply a load. So from the panel, the toolbar, I'm going to say, I want to apply a force, and I'm going to apply a force on this face, but as you can see, the arrows, they're pointing normal to the face. I want actually the arrows to be pointing down. So I'm going to be selecting a direction of where I want to push the force towards. So I can use a plane, I can use an edge of my model. So here I'm going to use the top plane. And once I've done that, I'm going to say what that force is going to be. So I'm going to use 2220 newtons, and want to make sure that the arrows are pointing downwards, right? So I want to be pushing down. And once I'm done, I'm going to actually run this study. One-click button, it's going to mesh it in the background. Once the mesh is solved, it's going to run. And very quickly, I've got results on the screen. Now, as you can see in my results, these are my default result plots that show up. I can add more, I can use sections and things like that. Typically, the first thing I like to do is go straight to animate for a couple of reasons. This is going to be the validation that I've actually set the forces and the restraints properly. So if this moves in a weird, bizarre way, probably I didn't set the simulation up correctly. But really quickly, I can see that, yeah, this is the displacement I'm expecting. So very clearly, we can see that. Now, you have to be careful. This is actually deformed. So there's a deformation scale, so we can actually see the deformation. So it would not, in real life, deform that much. But there's a scale to it. So these are my stresses. You can see the hot spots, right? In red, right over here. So you can see that might be of concern. But when we look at the stresses, the von Mises stress, you see that the yield strength is 140 megapascals, and at most I'm going to 16 megapascals. So I'm way over designed at this point. I can also go ahead and look at displacement. Again, if displacement is of importance, I can double check to make sure I don't have too much of that displacement. And then factor of safety. When I look at that factor of safety, I realize right now my factor of safety is around 9. So again, this is, in my sense, over designed. So we need to do some changes to that to make sure that we have something that doesn't need to be that strong. Now, this is, simple linear static. What I'm going to do now is call up the trend tracker. So from the menu, simply right-click the trend tracker, and you're going to see the new trend tracker icon appear. I'm going to right-click and set a baseline. Remember, when I do that, it's actually going to record the different iterations and the history of those iterations. So if I expand the trend tracker, you can see that right now I'm tracking actually 3 different components or properties, the mass, the stress, the displacement. But I could actually add some recording points or data to that. So if I expand the mass, you can see here I only have 1 iteration, so that's my mass. Over here, that's my stress. And over here, that's my displacement. Now, let's do some changes. So we've seen that it's way over designed. So maybe the one thing we might be tempted to do is make that part a little thinner. So I'm going to just dial it down just from 16 to 14 millimeters. So not a big change. And very quickly, simulation tells me, hey, if I go on the what's wrong, it's going to tell me that my information is not current. So I might need to update the simulation. Really easy. I just click on Run Sim, and there it goes. It just simply reruns the simulation. And now we can expand the trend tracker and see what the trend tracker is actually doing. So you see now the trend tracker is actually starting to record what's changing in my model. So here's the mass, here's the stress. So obviously the stress went up a little bit because the part is thinner, that was expected. The mass went down, that also was expected. and the displacement went a little bit up. Now let's do some more in-depth changes. So I'm going to go over here, and I have a feature I'm going to unsuppress, and that's a cut right through the model. So again, going back to simulation, I can simply update my simulation study to update the results. Now I could at any point go ahead and actually review the results, just like we've done with the stresses, and animate this information again. So you see now if I'm animating the stress, it displaces differently, obviously. But again, the trend tracker is just keeping track of everything. So I see now that the mass on the third iteration dropped quite drastically. But when I go to see the stresses went way, way up. So I removed a lot of mass, but because of that, the stress, peaked up very highly. So again, maybe that's something of concern. And if I look at the factor of safety, a factor of safety of 4, maybe I want to get a little bit more, maybe not that of an extreme change. So again, going back to the feature manager tree, I'm going to unsuppress the web, the internal web. So you see here, if I do a section view, you'll see that I went from a part that was full in the middle, right, to a part that was hollowed out completely, and now I have a model with a web in the middle of the part, a thin web in the middle. So again, going back to my study here, I could simply update this study, and again, you can see how quick this is. It's a simple model, but still very fast. And going in my trend tracker, now I can look at all of the data. So you see that on the third iteration, the mass went way down, but even though I just added that little web, the mass went up a little, but not that much. And then when we compare that to the stresses, we can see that the web, again, even though there's a little web we add, the stresses went way down, almost identical level to the second iteration, which was a full part. The thickness of the part was full. So for me, that's a good design decision, because adding a little more weight adds a lot more strength to the part. So these, the trend tracker is the kind of thing that allows you to do that, and it also captures a gallery of images. So as you go through, it's actually capturing all of those images. So you see here, you can actually look at the 4 stress plots side by side. So this is the first one at 16 millimeter, 14 millimeter width, with hollowed out center, and now with the web. And I can do the same thing for the displacement. No, sorry, the first slides were the displacement. These are the stresses. Again, I can compare second, this is the second iteration, third iteration stress, fourth iteration stress, and also go on like that. So again, a lot of information is captured using the trend tracker, and that makes it a really useful tool, especially when you want to compare your designs and see what type of decisions you're making with your design. So that was for the trend tracker. Now let's shift gear a little bit, and again, we're still talking about simulation standard, fatigue analysis. Now with fatigue analysis, what the idea with fatigue is the definition of fatigue, first of all, is the weakening of material caused by repeatedly applied load. Now, why is that important? Because when you load a part cyclically, right, you add load, you remove, you add the same load back, you remove it, you put it back, you remove it. Over time, let's say I have a part, the material will weaken over time. So let's say I have 200 megapascal of load, 100 cycles. It's great if I do 100 cycles. If I do 1,000 cycles at the same load, still good. But guess what? If I go, for example, this is a curve for aluminum. If I go to 10,000 cycles, it's going to break. It's the same load. It's just that over time, it's going to affect the material. It's going to break it. Now, again, why is that important? Fatigue analysis allows you to evaluate performance under cyclic loading. That I just mentioned that, but it will predict how long the product will last, and that's really key, especially if you have to honor a warranty. You don't want things to break while they are under warranty. If they break after, okay, customer is aware that it's out of warranty, they repair it and they pay for it. But if it breaks under warranty, you're responsible to assume all the costs, and that could be extremely costly for a company to assume a warranted product. So the idea with fatigue analysis is that you can modify your existing design to extend the work life and also identify critically damaged areas. So again, we'll take a quick look at a typical case study that we can use with fatigue analysis. So let's look at this example here. So we have a crank for a bicycle, and as you know, these are, there's a load applied to them cyclically, and these actually on a bicycle are something that break fairly often. If you do a lot of biking, you can see a lot of cases where it will just snap after an amount of time. Here's a picture where you actually see the fatigue starting to happen, the crack there. So these are things that can be easily determined using fatigue analysis. So we're going to walk through this problem, and that's a design of the crank I have inside of SOLIDWORKS. And I have 3 different designs, and I want to figure out which one's going to last longer, and maybe which one not necessarily last longer, but last long enough, let's say. So it's under warranty. It doesn't break under warranty. That's what I'm looking for, really. So how we're going to set it up is fairly easy. We're going to apply a load on the pedal, and then we know that for a period of life, a cyclist will run this set for a couple maybe years, depending on the amount of time they're on their bike. We want to look for maybe 7 million cycles. Make sure that it doesn't break before 7 million cycles. So how do we do that? Again, let's jump into SOLIDWORKS and go ahead and take a look. So here's my crank inside of SOLIDWORKS. Let's get there you go. Awesome. So here's my crank inside of SOLIDWORKS, and these are already set up just to save some time. So let's walk through the design. So first of all, I've basically set what we call the hinges. So the 5 holes that you see here, these are my first connection point to the bicycle. So I'm going to set those as what we call fixed hinge, and I'm going to do the same thing with the back cylindrical face here, right? And it's going to react like we see on the animation here. Once we've done that, we're going to apply a load, and the load is going to be 1,350 newtons on the pedal. You can see the arrows here, so that's where I'm applying the load on the model. And then when we run the simulation, we can start looking at stresses. So for now, that's just a linear static analysis, nothing more than what I've just shown you. Now with fatigue analysis, what we'll do is that we're going to start by a linear static analysis in this case, and then in the fatigue analysis, I'm going to add a loading event. Now what this is going to be is that, like I said previously, I want to check for 7 million loads, and I'm going to apply a load called zero base. So what does that mean? It simply means that how am I going to apply the load? Am I going to apply the load in the positive space and then apply the same load in the negative space, or I'm simply applying the load and releasing the load? So really what we're doing here is what we called a zero base. So we're basically applying the load on the pedal, removing the load, starting over like this, over time for 7 million cycles. So once I've done that, I run the study, and fatigue analysis is fairly quick to run. And then I got different plots, and these plots can be either damage percentage. So you can see here there's an area of color, and when you look at damage percentage over time, you can see that the damage is 176%. So if it's above 100, that means it will break before the end of the 7 million cycles. So that means that this design would not be a good design. But then another result we can look at is the life expectancy. And now we're probably concerned about the minimum life expectancy. And here we can see that the life expectancy is about 4 million cycles. Now again, we were looking for how much? For 7 million cycles. So obviously this design is no good. Now, how do we go about and look at that? Well, fortunately for me, I'm using configurations inside of SOLIDWORKS. So it's very easy to simply switch configuration, apply the same load, and rerun the study. So again, if I go back straight to the second iteration to the fatigue, so we can see that now the damage percentage at its highest is 51%. Life expectancy is actually like close to 14 million cycles, so that's actually twice as much. And then if I go to my third fatigue analysis, I can again activate my configuration and look at the results for this one. And I can see now the damage percentage, the result life, etc. Now, one thing that is really cool, though, with simulation is that when you do all of these types of studies, you want to compare them side by side. It's just so easy. You say, let's first start with the stresses for each of the 3 iterations. So I got iteration, my design number 1, my design number 2, and my design number 3. And I just want at this point to look at the stresses, click OK. So it's actually putting the 3 plots side by side, and now I can look at the results for all 3 of them really quickly. So you can see here, depending on the designs, you can actually see something really interesting. You see that the stresses, they actually move depending on the design. So the maximum stress on these 2 designs, the 2 on the left, are positioned pretty much in the middle of the arm, while this design on the top right, the maximum stress is in one of those corners. So that's interesting. Another thing we can do, as we were saying, we're mostly concerned about fatigue at this point. So again, I can go ahead and compare the results. And pretty much like I've done previously, I'm going to say, this time I want to compare the life of these 3 designs. So let me just go in the tree here and say, I want to compare the life of the 3 designs, click OK. And again, really quickly, I got life expectancy of all these 3 designs. So, design number 1 here is about 4 million cycles. This one, design number 2, is about 14 million cycles. And design number 3 is actually 1 billion cycles. So what does that tell me? So again, going back to my case here, what I wanted to do here is really compare all the designs together. So if we recap all of those 3 designs, we'll realize very quickly that the best design for this example would be my design number 2. The design number 3 is basically, again, over-designed. I don't need that much life expectancy, and maybe to some degree, I actually want the part to break sometime, so someone can come back and get a better part. In a couple of years from now, I'm going to be designing better, better components, so I can replace them. So, these are the types of simulation that we can, figure out using fatigue analysis, for example, right? So back to fatigue. So again, these are types of simulation are part of simulation standards. The fourth thing that's going to be part of simulation standard is going to be motion. Now, again, when we talk about motion, there's two types of motion, so you have to be careful. There's time-based motion, that's part of simulation standard, and SolidWorks Premium, if you have SolidWorks Premium. And then we have event-based motion, which is Simulation Pro and Premium, and I'll show the differences. But if we focus right now on motion, the time-based motion, that's part of simulation standard, really what simulation standard or time-based motion does, it's a tool to help size things, simple things, you know, help me size a motor, an actuator, understand power consumption, optimize springs, dampers, simulate cam drives and latch mechanism. So, you know, a simple animation probably like this one here, right? You have a component, you say, okay, I want to push for that amount of time, for that, you know, that amount of force. I got some weight or some forces applying on the tips. So in this example, this is a jaw of life, you know, to get people out of car accidents. And you want to understand the power consumption, how much power it's going to use if I want to open, you know, a door that's been crashed and shut down. So I can understand that using motion simulation. Right. So let's recap a little bit. So what we've seen so far is just simulation standard. I'm going to look at the time here. I just want to make sure we're respectful of everyone's time. But there is still a lot of stuff in simulation standard. And for a lot of people, that's going to be your first step into simulation. In fact, it's going to be actually cheaper to go, if you have a license of SolidWorks Standard or Professional, it's actually more cost effective to buy SolidWorks Simulation Standard rather than upgrade your SolidWorks seat to a premium seat. Over a year, if we do the math, it's going to be more cost effective. So and maybe Joel can touch on that, but really it's the easy way into simulation. So we have, again, linear, static, and time-based motion. Both of these we have in SolidWorks Premium, but simulation standard also gives you the trend tracker and fatigue analysis. Really two good, nice tools. So let's expand this to simulation professional. What do we have in there? Well, in simulation professional, we're going to add a number of types of simulation, and I'm going to touch on them. Also add a number of simulation tools that's, you know, part of that, right? So the first thing is going to be frequency. So frequency is going to be used to check for resonance, right? So every component resonates. If you subject to a certain, you know, vibration, it's going to resonate. And if that vibrates too much, it can cause the destruction of the part. So this is something that should be avoided at all costs. So frequency will calculate the natural frequencies of the system. So it will tell you at what frequency it will resonate. It won't tell you what's going to happen if it does, though. It's simply going to tell you it's going to shake, vibrate, or resonate if it's subjected to that particular frequency. So that's the first thing that simulation, that frequency will give you. So here's an example. So it's only giving you the mode shapes, right? So how it's going to resonate, but it's not really telling you what's going to happen if it does get into a resonant state. So next type of simulation is going to be buckling. So what's buckling, or some people call it collapse? It's a tool to analyze slender structures, you know, thin, long structures for critical buckling factors. So for a case like this, for example, a little stool, you know, the legs are slender, they're fairly long, and if I subject a lot of pressure to it, it's not going to crimple up. It's going to support it, and at one point in time, it's simply going to snap very suddenly. So that's what buckling is. And here, if I play that video, you can see basically the buckling factor. So it's going to tell you at this load, that's where it's going to buckle. So any type of structures like these, so like weldment support. So here I got a tank, and I'm curious to see what the leg are going to be doing. So in this case, again, we're able to determine that after a certain load, that on the right-hand side, you see that leg, that cross brace is going to, pop open, and basically the structure is going to crumble down. So this is the type of analysis we can do with buckling analysis. Next, thermal, or I said thermal structural analysis because we also do have thermal capabilities in our CFD tools. And really the difference is thermal is a good tool to evaluate temperature changes, and it's good for heat transfer inside of the solid. So for example, I've got a part like this, and I want to, there's a heating component. I just want to see how much the part is going to get hot or cold. That's a good tool to do it. And I always use, a word of caution if there's fluid involved. If you have air flowing around the part that's going to cool it down, or if it's any type of liquids involved that, heats or cool, and you still want to do thermal analysis of the component, you should actually go into flow simulation, because flow can actually calculate both the thermal effects of the surrounding fluid, but also the thermal effects of the component as well. So there's added capabilities there if you need it. So not everyone needs that. Another type of simulation we have inside of Simulation Professional is optimization. Now, optimization will actually run multiple scenarios to test series of design variables. So here I got a wheel, and I say, okay, this is the load I'm going to be applying. Go ahead and figure out what's the best. Now, it's going to actually find the best design, but it's going to find the best design based on your modeling structure, right? So it's going to go ahead and change a sketch dimension or a feature dimension or a thickness to figure out what's the best scenario. So it's basically a little bit like rule-based optimization, right? So you have to know what to look for and what to optimize, what kind of features in your design tree you want to optimize, and that's what it's going to do instead of you doing it manually. Another type of simulation we'll find in Simulation Professional is going to be the drop test. So the effects of impact of drop components. So basically any handheld products, should need some type of drop testing. So here's an example with a pair of binoculars. So I'm dropping the binoculars on the ground, and now we can see what's the effect of the stresses on that binocular as it hits the ground. And I've got different settings, and it could be on concrete, it can be on different types of flooring materials, and it's going to give you that understanding. Another type of simulation we will find in Simulation Professional is the pressure vessel simulation. So by definition, a pressure vessel is a container designed to hold gases or liquids at pressure substantially different from ambient pressure. So in a past life, I worked for a company that produced propane tanks and other types of pressure vessels similar to these ones here. So this is familiar to me, and it's bound by a different set of rules than just regular simulation rules. So, and we've got those built into the software, and these are actually different examples of pressure vessels. These are just, again, different types of pressure vessels that you can find here and there. If you look around, you'll probably find some of those, close to home. The other type of simulation is the event-based motion we'll find in Simulation Professional. Remember, I mentioned that motion has two types of motion simulation, time-based and event-based motion. So event-based motion, the difference is really to simulate complex machine operation. some things that are triggered by sensors, by optical lasers, automation, really more like automation. And here's a good example of a machine where you can see the table index, it stops, you can see some operations happening, right? So you can see some of the robots or the actuators going up and down. You can see another actuator that's rotating to grab another, component of the assembly line. So this is the type of event-based motion. It's just so much easy to do that in event-based than time-based motion, because in event-based motion, you can simply say, okay, when this motion is completed, start the next motion. So now when you have to do some changes, it's much, much easier. So if you have any type of complex simulation like these, that has triggers and sensors, actuators, on-offs, things like that, you won't likely want to go to event-based motion. That's going to be the best deal. So next up, 2D simplification. So we talked about some of the simulation types. 2D simplification still follows of the simulation types, but really it's a tool to reduce the original 3D problem into a 2D problem. Now, why would I want to do that? I want to do that just to do it quicker. Simulation-wise, simulation in general is a resource, intensive application. So as much as I can simplify it, I can get my results faster. But the beauty is that with 2D simplification, you don't let down on precision. So you can actually get better results faster using 2D simplification than you would with traditional 3D models. So basically, when you have something like this, so on top is the actual 3D model, you could simplify it to a 2D section of it and drastically reduce the computational time it takes to give you that result. So again, really useful tool. Next up, the load case manager. So we're starting to talk about the productivity tools in the packages now. And the load case manager is a tool to evaluate the effects of various load combinations. So let's say I have this bracket here, and I'm going to load it maybe vertically, maybe sideways, maybe there's going to be a torque applied to it. So think of it as a support maybe for a monitor. Someone might, tip the monitor and might, want to twist, or, the load's going to be applied vertically, but what if, there's other types of loads cases to that. So basically the load case manager allows you to combine all of these loads and run your simulation based on the loads. So you see in the graph down here, you see the different load cases. There's a load downward, lateral, 20G vertical, upload, 20G side load, torque. And now I can run my simulation and say, okay, my first load case is going to be these two, the second load case is going to be these two, and the third load case is going to be those two. So you can combine those different loads and create a load case combination to help you automate the simulation process. Now, next up, we're going to see sum modeling. So sum modeling allows you to create a simulation on a large model with fairly coarse setup, just to have time benefit to run it. But let's say I'm really important, what's really important to me is that middle part here. So I can do what we call a sub-model. So the ability to accurately test large and complex 3D models by performing precise simulation analysis for specific areas of interest. So it's faster, first of all, than to take the whole model and change the resolution of the whole model, and it's more efficient. So it's just a faster way to get to the result you're looking for. So any type of designs like these where there's actually a part that's critical, but it's part of something bigger, that's a good way to get at it. Another tool that we're going to see inside of Simulation Professional is for welds. So different types of welds, these are two of them, edge and spot weld. So it will help you estimate the size of a weld that's needed to attach two metal components together. And basically will tell you what's the best size, and if you specify a size, it's going to tell you if it's going to break or not. Also, the web portal. So that's basically an access to a library of materials online. So we already have a lot of materials inside of SOLIDWORKS, but especially when you get into the plastics or the non-metal materials, there's a chance that you might actually need to add that to your library. Now, with the online library is that it's available online. You don't need to necessarily do that from scratch. So you can do it yourself. You can simply go and grab the material. Now, that's reserved for customers on subscription only. And this is new for 2018. Actually, a new tool we're adding to Simulation Professional in SOLIDWORKS 2018. Very interesting, very high-end type of simulation called Topology Study. So basically what Topology Study is a tool to help optimize the design form of your design. So I talked to you about optimization a bit earlier, but that optimization is based on the features of how your part is built. This is a form of optimization, but it's not based on anything other but the topology of the model. So basically, you're going to set some goals and real-life conditions of the component and simulate your load cases. And you can also include manufacturing processes in there as well. And it's going to give you direct results for traditional or, if you want, for additive manufacturing type of manufacturing. So let's take a look. So this is really nice. I think it's worth mentioning. So let's take a look. So let's go over to this, and here's my example. That's my assembly. And I want to optimize the part you see on the down right. There we go. So we're going to simply start the study real quick. So as you can see here, I'm setting a force of 200 newtons, and then I'm going to set some goals. What do I want to do in my study? Well, there's different types of goals. So it can say stiffness, or minimize the displacement, or minimize the mass. So a lot of people will simply go to the best stiffness to weight ratio. So as I select that, I want to say, what's my constraint? What do I want to do or not do? And here I'm going to say I want to try to reduce the weight by 70% if I can, reduce the mass by 70% if I can. So once this is done, I'm going to go ahead and say okay to that. And you can see the load by the magenta arrows. And what's nice, again, is, as I was saying, I have controls over manufacturing. So a lot of people might want to do to 3D printing, but a lot of people are using traditional manufacturing processes. So if I want to do that, I can say, hey, I want to make sure that I can actually demold that, or either it's going to be molded, or maybe it's going to be stamped. That's another method, or simply traditional CNC machine. So I can define how this is going to be made. So once this is set, I'm going to go ahead and run the simulation, and actually we're going to jump to a finished result. And on the screen, as you can see, the topology has been optimized to my design. These features, as you can see them, didn't exist. It's SOLIDWORKS that came up with the best topology for that design. So very easily I can do that. I can actually create what we call a smooth mesh. If you want to send that to a 3D printer, you can actually save your smooth mesh to STL and send it out to a 3D printer as is. But now I can use that as a basis to redesign this part so it actually as strong as possible. And as I do that, again, I can, using the sliders, I can define if I want to remove a lot of material or remove a little material. And very quickly, I'm able to define or get to the optimized model. So, and that's really a really interesting solution. You know, again, the ability to show this in my 3D design so that I could end up with, actually, let me show you the finished result of that is actually this little part here. I hope everyone can see that on the webcam. But this is actually the output. And that's how I came to that design. I actually used simulation on this part, and it gave me the optimized, you know, the topology optimization. I used that topology optimization to remodel this finished part. So this is a great way to get at something like this, where you're not sure what the, you know, your anchor points, you know the pivot points, you know, these are critical, you know that some of these faces are critical as well. They're you know, maybe load bearing or whatnot. So you can define that. But the shape, the internal shape of that bracket or that support, I didn't really know. So this is a great tool to get at something like this, for example. So as we've seen, in SOLIDWORKS Simulation Professional, a lot of great tools as well. So we've covered a lot of them, most of them actually. The last thing we need to do is, oh, and by the way, Topology is going to be part of Simulation Professional now as of 2018. That's a new feature in 2018. So Topology optimization is in Simulation Professional. Now going to Simulation Premium, and I see the time running, so I'm going to do that quick. We're going to add again some more simulation tools. So we're going to talk about nonlinear, all the dynamic types of analysis, and composites. So these are the three key items. So you see here, there's you know, 6 of them, but I kind of grouped all the you know, many of them together. So first of all, if we talk about nonlinear, there's a couple of reasons why you want to use nonlinear. First of all, if you have large deflection. So this is a good example. First of all, it's going to be made of plastic. Plastic's a nonlinear material, but also there's a large deformation of the part. You want to go to nonlinear analysis to be able to accurately simulate that type of simulation. Also, if you have a lot of contact analysis, you know, pushing, sliding effects, simulation, nonlinear simulation is going to be better for that. And also, any type of plastic or rubber. So like you see here, you know, that's a seal, and you want to see either, you know, how tight the seal is going to be or how much pressure the seal is going to apply on the outside components. You want to go to a nonlinear analysis to be able to get a good result of that. Also, all the dynamics effects. So as I mentioned, there were a lot of dynamics shown on the slide. I kind of grouped them all into the same slide here. Things to calculate the effects of vibration. Remember when I talked about frequency, I told you that we can detect what's the mode shape, how it's going to, at what frequency it's going to vibrate. With dynamics, you can actually say what's going to happen now. So effects of vibration, any type of impact, shock loading, you'll want to go there. If you do any type of electronics, chances are you're bound to do a shaker test. And basically a shaker test is that you create a component like this, you put it into machine, and the machine just shakes it, and to see that nothing breaks loose. So if you do any type of component that goes either electronics that go in planes, trains, or automobiles, chances are you're going to do some types of testing like this. So now you can actually see what's going to happen as it vibrates, as it shakes. Another type of simulation is going to be earthquake analysis that we can also do inside of SOLIDWORKS Simulation Premium. Here are just a couple examples: suspensions, test fixtures, mounted machineries, building bridges, aerospace. These are the areas where we want to use dynamics for. And then last here I'm going to talk about is composites. And there's 2 types of composites we support: laminates and sandwich. And then we're going to, you know, typical material is going to be carbon fiber. It could be something else, but that's where we're going to see it quite often. And these days we can see those materials expand in their use quite drastically. So we can see now on storage tanks, building panels in marine, very popular in marine, furniture, automotive, and aerospace, also very popular. But also we're starting to see a lot of those materials in high-speed manufacturing equipment because of the stiffness to weight ratio. So if there's any high speed, it helps a lot in these types of equipment. So a quick recap, final recap, before I let Joël kind of wrap things up. So in simulation premium, a high-end simulation product, we're going to see the nonlinear, all the dynamics types of analysis, and also composites. So again, actually, these is the whole product portfolio. If you have any questions, I see time is running short, so I see that there might be a few questions, so I'll answer them via email after the session. But if you have any types of follow-up questions, please email me or Joël. But in recap, what you have to look for when you look for simulation package is really what types of simulation you want to do and what tools you need to help you accomplish those simulations. So that's really the two types of simulation you want to look at. We have, again, 3 different types of simulation tools: standard, pro, premium. The webinar is being recorded, and I'm going to post it a little later on our webpage. So here's the QR code to get to that webpage. Sorry, I saw that I put a French slide in there. Both seminar French and English are posted on our webpage. So if you want to review that a little later on, please feel free to go there. Again, if you don't have time to snap the picture of that QR code, just send me an email and I'll share the link with you. So with that, I'm going to leave it off to Joël to sign it off. Joël?
Thank you very much, Michel. So lots of information, as you all can see, because there's lots of functionality included in simulation, a number of things that can be done, can be worked with, can be tried. This is before Christmas. We do have some incentives to help companies get into simulation if you haven't done so already. We've got great ways of getting into simulation standard to get you going, get you started. And we're going to try and do everything we can to get you a Christmas gift under the tree if professional or premium is where your company needs to be. Obviously, there's a whole lot more functionality in those products, and but we'll do what we can to accommodate if that's what you need. So lots of different things that you can do to get more information and to see the particular modules that you wanted to see or think that would apply to you. Obviously is reviewing this webinar again if you want to see it again through the recording, is contacting Michelle or I if you've got some specific questions. But of course, a reseller that you're normally working with would be very happy to show you something individualized for your company and assist you in getting into some of these simulation capabilities. So with that, I will thank you once again for joining us this Friday morning, and this is our last one before the end of the year. I wish you Merry Christmas and Happy New Year a little early, but we're already getting into that, and we will see you on webinars and hopefully live events next year as we start hosting them in January. So have a great day, everyone. Have a great weekend, and we wish you all the best.
All right. Thank you, everyone. Bye.